Hi, everybody. My name is Shady El Damaty. Maybe I'll start with a little bit kind of context intro of myself. I actually have a background in neuroscience. My expertise is in pulse sequence development for MRI, and specifically ML applications for better understanding how biological attributes and characteristics manifest in observable phenomena like resting state functional connectivity. So a little bit towards the end of my PhD, I was building actually an HPC, a high performance compute cluster in collaboration with a bunch of other institutions to do something with a lot of data. We were trying to estimate cognitive age. And it was there that I kind of really got exposed to a lot of ideas around cryptography and IPFS, and then set out on a mission to recruit a team to build out what would be fundamental infrastructure to solve some of the problems that we ran into. And I found myself down a very circuitous rabbit hole that's led me to where I am today. So thank you to Alice and the Foresight Institute, because it allows interdisciplinary work to flourish in environments like this, and really fortunate to get to meet and chat with some of you folks. So also, small disclosure, this is a different talk than the one I planned. So really briefly, the other talk, if you are interested, do find me and chat about it later, is about different types of Nash equilibria that emerge when we start thinking about cooperation, specifically when models for knowledge generation are produced in zero knowledge, right? Specifically, how do we think about epistemology from a cybernetic perspective when ZK is kind of an embedded component of that system, and how does that apply to AI and AI alignment? So definitely down to talk about that later. But today, what I really want to talk about, because I've gotten so much inspiration and ideas and seemingly opportunities to kind of push some of these ideas along, is specifically how do we use ZK to improve security usability, first off, and secondly, to just make the internet a better, more self-sovereign place. And I think, I'm not going to really drill down into this because I think we all are here for the same reason, but there's this idea that we've kind of already let the genie out of the bottle, and now we're falling down a gradient as a society, as a civilization. And that gradient still has a couple bifurcations coming up, and a lot of the actions or things that we decide to work on today and dedicate our energies to is going to determine which gradient that we bifurcate along. So do we end up in a unipolar, right, state where, for example, we're all basically enthralled to a central agent or central protocol that gives us our roles and delegates our activity and tells us how to be happy? Or do we end up in a more multipolar universe where everyone is uplifted to be their best version of themselves, where there's a protocol that acts in the service of individuals? And I think what's really key for that is, and I'm taking this straight out of the Gaming the Future book, is developing technology as well as relationships, institutions, and organizations that uplift voluntary cooperation and distributed networks. So really solving the problem, how do we coordinate goal-directed group behavior around really complex topics, right? And doing so in a way that's multi-scalar across problems that might be in the laboratory, as well as problems that might relate to, for example, like governance issues with like alignment, right? Or legal, think about legal challenges and how we as a society accept values and organize around values. So one thing that's really resonated with me over I think the past 3 years now, I guess, since I've been in this space, is this idea that distributed ledgers are really great for this. And specifically, if we build our technology for whatever it is that we're pursuing with public key cryptography, where the individual is the sole owner and of their cryptographic keys, they hold it in their device, in their pocket, on their phone, and they can attest to different things that they do, adding to a chain of provenance that could be tracked with or without privacy, with privacy or in a public setting. The problem is, though, that distributed ledgers are problematic because they have to be public by design. So if we take an example, for example, like say a vote on an appropriations bill on how to use some tax dollars. If we put that on a distributed ledger and say, let's use Snapshot, if you're familiar with Snapshot, it's a way of voting on blockchains and on Ethereum blockchains. And everyone in the country was given a DID, and they can vote yes or no. And if you look at the ledger, you'll see a bunch of strings, right, that begin with 0x, because we're doing this on Ethereum. And you'll see whether they voted yes or no. But what you won't know is what really is the nature of those DIDs. Are they real people? How do you know that somebody isn't Sybil attacking or making many, many DIDs and paying people or bribing people to vote one or the other, like for example, a contractor. So one of the major issues around any public blockchain system to help us with this problem of coordinating together is that Sybil attacks are really common. It's really difficult to hold people accountable, right? So because we don't know who the DID belongs to, we don't know who to go after during a rug pull or during a hack or during some sort of collusion like this. And in most cases, like I've alluded to, privacy is pretty much black or white. I think this is something people have been, a lot smarter than me, have been thinking about for a very long time, and it's pretty clear that reputation is key to solving this. But building reputation on-chain is really, really hard. We have tons of really great examples, like POAPs, which is proof of participation in real-time events. I don't know if you've ever tried to issue a POAP for an event, but you end up getting POAP farmed. I've had an event with like 10 people in a room, and all 1,000 POAPs were somehow, issued. I have no idea how that happened. And yeah, and there's this concept of soul-bound tokens. So okay, well, you just make attestations on an individual, non-transferable to that DID, and then you can basically be somewhat sure about that. But however, how do you verify or have an oracle that can link that off-chain behavior on-chain, that the person is in the room, that they are that person, that they didn't pay their friend to go take the SAT, for example? It's a very difficult problem. How to prevent resale of DIDs, right? So if you just have a key that you keep in your pocket and you give it to somebody else, say, hey, I'll give you $100 for my World of Warcraft character or my Ethereum, NFT Bored Ape or whatever. And last, how do you really maintain user consent throughout this entire process without infringing on privacy? And I think that's not obvious. Yeah, so I did assemble a slide, so I'll try to speed through this really quickly. So what we've done actually is we built a generic architecture. I should mention also I'm a co-founder of Holonym. That's who we is. I'm representing my team here. And we built a generic architecture for taking off-chain claims about an individual and putting them on-chain with privacy. So basically the way it works is you can bring any sort of attestation about yourself, such as an ID, like a biometrics, like a passkey, for example, social security number, and you can verify with any third-party authority, and once you're on-chain, you're completely private, but you can produce proofs on yourself, such as that I'm a real person, I'm not a bot, I have or haven't voted, I'm from the US, et cetera. One key thing to this, and I would love to talk to folks in legal engineering, is one major challenge is accountability. So we've also built out something that we call ZK escrow, where you escrow your identity to an MPC network, and you can gate access to it based off of if some criteria are met. So for example, you can still maintain off-chain legal compliance and say, here are the laws, they're encoded in the smart contract. The smart contract is still key, but that information or that data or that identity won't be disclosed unless certain conditions are met. And lastly, and most importantly, this is something that I've really been working really hard on with our team, is how do we really have seamless key custody, such as that if I lose everything right now today, and I'm pretty much screwed, I don't have my ledger, I don't have my wallet, can I just present myself as an individual, present my identity, and be able to recover shards that can be used to construct my private key from a distributed network? And this is a very non-trivial problem, and would love to talk to you guys about it. We think we built a solution that's mostly good, and you can check that out at docs.silk.sc. I would love some feedback on that. And yeah, I'm not going to talk about any of these slides because, yeah. So where do we want to go? Secure key custody, I think, is the most important for us, and being able to build streamlined UX to make security usable, and building specifically towards a future where anyone can produce proofs on their identity on some distributed ledger and be able to participate in governance. And I think this is going to be really important also for thinking about how our data interacts with AI. And that's the end. Thank you.
Wonderful. Thanks, Shady. Do you have a question? Yes, one question over here. Stay here because I need your chat.
I'm really skeptical. I'd like to see the death of PII as a component of identity and a move to more corporate identities where an identity is a cloud of devices and you have nothing to say about the human. But my question is how do you protect in a scenario like this people's secure online identities, the keys and things like that, from PII fraud, which is extraordinarily common, much more common than hacking devices?
Yeah, so you're asking specifically about what if somebody steals your identity, say like your driver's license, and then uses that to reconstruct
Yeah, there's basically no piece of PII that's useful for authentication that hasn't already been leaked by hackers on the internet to everyone.
Yeah, I think the best way to secure your account, your keys from someone that might steal a physical document or a deep fake that impersonates you is to rely on attestations from the hardware, which actually was going to be my challenge to you guys. I think that it's really important, first off, to embed multi-factor authentication, so making sure that there's no single point of failure. For example, even if our server, which acts as an intermediary between an on-chain event, and if that server is infected with malware, that you're still able to consent in or out of a transaction. You either get a push notification or you need to pull out your hardware key and plug it in. I think that's one way.
So I agree. But why have the PII reset at all then? In fact, why have PII involved at all?
Yeah, I think the idea is to get closer and closer to an attestation of the individual, right? So I think having that hardware key in your pocket is still a weak point for security on behalf of the user. I think that the hardware device can be useful and can be used to shore up your ability to recover it. One thing that we're working on right now is ZK-based wallet recovery. So right now it works with email, and the idea is that we actually use 0xPark, if you're familiar with them, a ZK regex. So you send an email from an account that you use to generate your private key, and you can match the RSA signature within the email header as well as some string within the text to prove that you did send an email to recover the key. Now, I wouldn't put like $1 million in something like this.
I'll stop bothering. The whole thing just seems to me like you're asking people to reset their password by proving knowledge of their username. It seems just completely backwards.
We'll take that into the working group, guys. What is the challenge that you want people to solve?
Yeah, I think one of the biggest challenges is being able to we need better hardware devices that can attest to, say, for example, a recording of an individual, whether it's a camera or a microphone, where the hardware device has some cryptographic key and can say that this person is that person that recorded themselves or their likeness. Being able to do that within a ZK snark, I think, is very desirable with low computational overhead, and that's non-trivial. And if you know how to solve that, would love to work together.
Awesome. If I didn't catch the question here correctly, then please update it.
I'll update it.
Okay.
Thank you.
Thank you so much, Adi. Wonderful. Next one up.